All right, so I'm going to prove the Pascal's identity. It can be any of these. They're both the same. We just substitute a k with a k minus one, and so we can have. So let's use the second one. The second one we have n factorial, right? This we're using this n factorial. Oh, over over we're using the choose formula, the binomial coefficient formula. Where n choose k is equal to factorial n minus k factorial and k factorial. And so this term will be this n minus 1 factorial times k minus 1 factorial. This becomes n minus k plus 1. All right. And then the next term is plus, let me move this. Um, so the next term is nk, so that's the same thing as the formula gives. So we can use the formula. This is equal to the last one is, well, we would have n plus 1 factorial over n plus 1 minus k factorial and then k factorial. All right, so if we prove this equation is true, then our Pascal's identity is true. So let me erase these. All right. So one thing you can notice is that we can multiply k by both sides. Yeah, k factorial. This cancels out. K factorial. This cancels out, and then we have a new k factorial here. Um, and then the next thing we could do is multiply everything by n minus k plus 1 factorial. So this would be canceled out if we have n minus k plus 1 factorial times this term. And we would have a new term on top, n minus k plus 1 factorial. And this one will cancel out because this is the same thing as that factorial. And so let's rewrite our terms so it's not too messy. We have that over that, k minus 1 factorial plus n factorial, n minus k plus 1 factorial. Yeah, plus 1 factorial. Uh, n minus k factorial is equal to n plus 1 factorial. All right, and so now we can, let's see what we can do next. We can divide everything by n factorial. Because if you divide this side by n factorial, you divide both terms by n factorial. And then so we have that equation. Yeah, that's all we need now because look what happens. Oh, look what happens next. Um, so we know that k factorial can be re-expressed as k times k minus 1 factorial. And then the bottom is still k minus 1 factorial and then plus. And then the next term, we can express this as n minus k plus 1 times n minus k minus, oh, I'm sorry. Uh, yeah. You have n minus k factorial, right? Because that's 1 above it. So we solve that. N minus k factorial is equal to, we can re-express this as this, as that, n plus 1 times n factorial over n factorial. And look how beautiful this is. You can just cancel everything now out, and we're left with k plus n minus k plus 1 is equal to n plus 1. And so we get, well, k minus k is equal to 0, and so we're left with n plus 1 is equal to n plus 1. And there we have it. We have proved this identity using algebraic manipulation and just substitution. All right.